is Greg Osri. I'm the founder of Akash Network. How many of you are here from San Francisco or traveling from San Francisco first? Wow, traveling. Wow. Wow. From a talk, huh? Awesome. Well, every AI lab's roadmap today looks something like this. More data, more compute, more scale. OpenAI wants to spend, what, $1 trillion on infrastructure? Microsoft spent about $80 billion on infrastructure this year. NVIDIA CEO Jensen Huang says AI is the next industrial revolution. They're not wrong. I mean, AI has, it's a substrate of civilization, and it has made tremendous progress. It's not hard to see why so much money is going towards this, these infrastructure projects. But no one, well, not many people at least, are talking about one thing, and that's really about what happens when the grid says no, right? Ultimately, AI needs energy. Until about a few months ago, I mean, in fact, if you saw Elon's recent podcast with Dwarkesh, it's all about energy, right? So this talk really is not about the hype. I want to talk about the wall that's preventing AI from scaling. So let me set a baseline first, right? In 2024, the global energy used for AI was somewhere around 415 terawatt hours. It's about 1.5% of global energy that was used by AI. And that was near zero not too long ago. The International Energy Agency, IEA, predicts, this is their baseline prediction, that by 2030, or 4 years, the energy will be anywhere, somewhere around 945 terawatt hours. And that's about double the energy. That's about 3% of the global energy. Now, you might ask the question, that's a lot of energy. Surely we'll be able to build, new supply, right? Well, we definitely want to build new supply. About $2 trillion worth of sovereign AI, sovereign funds have been committed towards these projects. I mean, U.S. alone committed about $500 billion in their project called Stargate. And I believe South Korea committed about $735 billion just for AI infrastructure. Countries, Saudi Arabia, UAE, India, all of them committed hundreds of billions of dollars to build AI infrastructure. Most of the infrastructure is for energy. Yes, there is some amount for the chips, but most of it is for energy. Only problem is the lead time for transformers. Transformers are these things that move energy, The lead time is actually anywhere from 128 weeks to 200 odd weeks, and that's about 2 to 4 years just to get a transformer. The problem is AI moves in months. We know how fast these models develop. So the speed at which AI is moving is fundamentally incompatible with the rate at which AI can be built. And Elon was very clear in his podcast about his frustration about the industry, right? And his thesis was like, we can't really build on Earth anymore. We got to go to space. There's some, I disagree with him on a lot of things, but there's some fundamental truth. These companies that build transformers are not tech companies. These are old established, companies. They can't move as fast. So that's why you see these lead times for these transformers and a lot more other problems. Now, why can't we build more generation? There are 4 main problems the way I look at it. And in May last year, I testified before Congress about this particular subject, about the challenges of infrastructure, right? The big thing is permitting hell. By 2030, you will need at least a nuclear reactor to build the latest model. A nuclear reactor produces about a gigawatt capacity, right? The permitting delays, the amount of time it takes from permit to power for a nuclear reactor is about 10 to 15 years. The last one we built in Georgia took about 14 years, right? And then you have the second problem, the supply chain is frozen, right? If you want to get a turbine, for example, Siemens Energy is a company that makes turbines that rotate, that's used for gas plants, by the way, right? So gas plants take anywhere from 5 to 7 years from permit to power. Turbines, they have about $158 billion in backlog, right? And they're sold out for 7 years. You got to wait 7 years to get a turbine. If you're Elon Musk, you'll go buy a company and bring the turbines to America. That's what people are doing right now. And third, even to get a permit, right, you still have to connect to the grid. In US, we have something called interconnect. Now, interconnect is public data, by the way. Anyone can look at interconnect queues. Interconnect is the network that you need to connect anytime you have new generation capability. ERCOT, for example, is Texas Interconnect. That grew by 300% year over year. They're not used to growing that fast. Now again, grid is this like physical copper lines. There's a limit on how much you can transmit, right? So you got to get a permission, and that takes months, right? I mean, years, sorry, months, years sometimes. And PJM grid, which is the grid that, the interconnect grid that serves Northern Virginia. Virginia is considered the data center alley. That's where all the data centers. They're going to fall out of reliability standards by June 2027. America, out of reliability standards of the electricity is going to fall out because of AI, and there's a big uproar now. The community is waking up. About $100 billion worth of data centers have been canceled a few years ago. I mean, to last year. And this year alone, there are about 300 new bills being introduced by local legislations to ban AI data centers. Last week, we saw this famous tweet. I don't know how many people are terminally online here, but this famous tweet about this dude who won, apparently some city councilor who won by canceling the data center project and instead got a park. You're going to see a lot of these things, and communities getting hurt. So in Virginia, the electricity prices grew by 100%, like double in like 3 years. And by overall, U.S. electricity prices are expected to increase about 8% average by 2030. That's going to create a lot of problem for a lot of communities that are underserved. Now, we're not even touching the surface of the problem. Here's a real problem. The real problem is moving the energy, right? So basically, So, like I said, like generation definitely is a problem, but moving the energy from the generation to where it's consumed is even a bigger problem. You know why? Because our grid is old. We've been having electricity for US and the West in general has had electricity for about 100 years. Most of the stuff we built in the 60s, and it's old. To upgrade a line, it takes a long time, right? It takes years of permitting costs. And nobody wants to upgrade their line because there are only 2 ways to upgrade a line, 3 ways actually. One is, well, lay out a new line. Nobody wants the lines in the backyards. Why? It crashes real estate prices every time you see a transmission line. Well, you can cut off the power, replace it. Nobody wants power to be cut off, right? That's unacceptable. Third is you can dig a hole under the ground, which is prohibitively expensive. And there are lots of reasons why you don't want to dig holes. So even if you produce, it takes about 10 to 15 years just to get permits to upgrade the grid, right? Even if you produce, it doesn't matter, you can have the fanciest solar farm in Arizona, the fanciest wind farm in Idaho. There's no way to get the power from Arizona to Northern Virginia, what's the point of production? So that's the biggest challenge today we see with a lot of renewables, that you can't really move the energy. No matter how much technology gets better and better, the offshore wind, very promising. Problem with offshore wind, you cannot move the energy, you can produce it. And then, I want to introduce you a second dimension of the problem, right? The ascension of agents. We all played, how many of you actually played with OpenClaw? Show of hands. Right, good portion. How many of you played with agents in general? Oh, wow. So how many of you played with agents total and OpenClaw? All right. Those of you who have not played, I have serious questions about your future career aspects. But anyway, so how these agents, they consume a lot of tokens. Tokens means energy, right? On average, agents consume about 10 to 40x more tokens than a human can ever do, because they're constantly working for you. They're constantly online. They're constantly proactively, working for you. In fact, they're so proactive, they won't even stop if you ask them to stop. Like anyone that uses OpenClaw will tell you, they'll, It'll just go on, right? It's very trigger happy. So when you have agents, when my home alone is controlled by agents today, I'm going to get into a scenario, or at least will be controlled by agents very shortly, all of it. It consumes so much tokens that it's not hard to see. And Gartner predicts by 2030, that's in 4 years, we're going to see about 45% penetration of agents in corporates. It's not hard to see because it's very, very obvious, right? By end of 2026, sorry, not 2030, by end of the year, 40% penetration. Right now it's about 5% penetration. With things like OpenCloud, with things like Cloud Cowork, with things like Cloud Code, for example. These are all agents that are doing amazing things, and it's not hard to see that they're going to go away. But here's the shift. Like with OpenCloud, you saw a lot of people buying Mac Minis, right? Now you can see the incredible shift. The agents are not in the cloud. They're moving to the home. I mean, Mac Minis are sold out. It's crazy to see the shift. Before you ask me if you're going to run compute at home, I'll be like, well, I started a whole company around it. But before that, I'll call you crazy. But it's not hard to see how that's happening, right? And I want to basically paint a picture. And this is the life I actually live. Oh, sorry. It's, say, 6:02 in the morning, right? You haven't moved yet. Your millimeter sensors. Have you heard of millimeter sensors? There's a new technology called wave sensors that can detect very minute movements. An wave sensor in my home detects that I'm about to wake up because it can see my sleep phase, it can see my breathing patterns, it can see my heart rate. It knows when you're about to wake up. So when it detects that, it'll start my thermostat for my coffee maker to the exact temperature that I want. Before even I get to the kitchen, the coffee maker is already running. By the time I check my phone, the coffee maker is running. So by the time I get to the kitchen, I have these microphones pretty much everywhere in the house that can pick up subtle movements, and that I'm walking. There's a presence sensor in the kitchen that knows I'm in the kitchen. The blinds go up, the lighting comes down. All kinds of adjustments happen to my day. By 6:08, my doorbell camera, for example, can pick up a vehicle parked in front of my street that I don't recognize. It automatically takes a number plate, cross-reference checks with any known databases, and logs a timestamp record in the security log and gently tells me what's going on. Doesn't really create an alarm. By 6:15, I have my dashboard in my kitchen that gives me a full overview of my day. And this is not future, this is today that's happening in my home, right? And you can see one pattern here. When I say everything that's happening, one pattern is one thing I keep repeating myself. All processed locally is zero cloud calls. Imagine the agent knows more about me than anyone will ever know. It's recording every conversation. It's recording every video feed in public areas in my house, and it does not go to the cloud. And this is the future that I want to present, right? The amount of data agents my AI has locally is about my heartbeat. It's every conversation, right? It's so invasive, it's so intimate that I would never, ever have anyone take this data out of my cloud, right? So, and now you got to ask your question, where does the data go? Now, I want to be very careful here. I'm not saying the companies that collect this data are going to use for nefarious purposes, but you got to ask your questions. Where does your heartbeat go? Where does your breathing patterns go? Where does your fights with your wife go? Where is the data going, right? It's not that these companies want to do bad things. It's just they all want to do the right thing, but they're structural problems. What if they're in a jurisdiction that you don't recognize or you don't really agree with? What if they get acquired? There are companies that do DNA testing that got acquired. What if they get breached? Worse, it happens a lot. Right? Happens a lot, right? In the age of wipe coding, who knows the security patterns with these things? So there are the moment the data leaves your network, it's unsafe. Doesn't matter how many safeguards you take, doesn't matter how much encryption you have, anything that leaves your network is fundamentally unsafe. And that is a point I want a local AI, even though it's not as capable as a cloud AI like Anthropic or whatnot, with agents, local AIs are extremely powerful, right? Claude's tweet this morning talking about distillation, where the Chinese companies are like distilling, I'm like thoughts and prayers. Where did you get the data from? Anyway, so it's only distillation if it's done in Silicon Valley, right? Everywhere else is called stealing. Anyway, so there's a lot of this data, and OpenAI is experimenting with ads, right? Now, what are the chances that all your private conversations will be used by an algorithm to manipulate you into buying? What if you had a fight with your wife and so all of a sudden you get an ad for Tinder? I don't know, I'm just saying. That could happen, right? People will use data in whatever means possible, and that happens a lot. It happens in Silicon Valley quite a lot. And that's why it's very, very important to have any data that you generate that's considered to be intimate, local to you. And so what does the solution look like? What does it mean when I say local? Okay, so we had a 15-year run with the cloud, right? We had, cloud era where your mobile phones are just a gateway to the cloud. All your data stays in the cloud. All the processing stays in the cloud. Your mobile phones become like this amazing ways to access because there's not too much power. 15 years ago, mobile phones increasingly got better and better. But really, the amount of power cloud has is asymmetrically super high compared to your phone. Now, in 22, we saw the ascension of the edge AI, right? So edge AI is basically the phones got smarter. Now you have some partial inference, definitely right direction, right? I mean, phones do have some local inference, they do. And in 2026, I want to introduce the idea of a home node. Now, a home node is, as you can see, one of the good patterns about AI is the models are getting smaller, models are getting smarter, models are getting a lot more capable to run in a Mac Mini style, right? The home node in my home runs about 6 5090s. It consumes about 5 kilowatts of power. I do have local energy that pays for the compute, so I don't have to pay PG&E, my life savings to run this thing, instead of paying thousands of dollars to cloud and risking my privacy, right? And what does it mean? Like, let me connect back to the actual problem we began with. What does it mean for the energy crisis? Well, here's the model I want to present. Create locally. All your data, all your AI runs locally, all your agents run locally, all the creation happens locally. You consume your local solar, you consume your local mini micro wind, local batteries, everything happens locally, right? And then your compute obviously runs locally. Both your agents run locally. And by the way, don't buy Mac Minis. You can run a VM, a Linux VM. You can run a Mac in a Linux VM. I don't know how many people know that. I mean, Apple open source, not open source, but they released their Mac OS. You can literally run a Mac in a VM, a VMware VM, or whatever VM software you have, a hypervisor, and you can run 10 different agents, right? Instead of buying 10 Mac Minis. I think it's the dumbest thing people are doing. Anyway, so you can run a compute locally, and your AIs in the models you can run local are very, very capable. Minimax is incredible. Minimax 2.5, for example, it's incredible at agents, right? Apparently, it's a Temu version of cloud, so it's basically the same thing. And the best part is, like, when you're not using it, you trade. You trade with your peers. Because most of us are not using compute. My agents are not that active in the night, for example, right? In the night, when they're not using my AI, they can trade the compute resources. And this is the incredible part of peer-to-peer systems. And more importantly, training is getting distributed. Training was primarily data center based or a colo-based activity, but it's getting increasingly distributed. I don't have too much time to cover it, but happy to talk offline about where the training is going. And together, I want to sum it up. Together, if we can create local AIs, if we can have local inference, local agents, we can create a more sustainable and a pathway, and we can actually solve the energy crisis, especially with AI going distributed now, AI training going distributed now, and AI inference most definitely going distributed means we don't need to rely on the grid. And agents, as they get intimate, privacy becomes a lot more important than what you think. And especially when you have no control, or the agents, because agents have agency. Agents have agency that you really can't say anything. I mean, they're very trigger happy. And in the future, I envision is a mesh of homes rather than a hub and spoke. And thank you for listening to my talk.